All right, hey friends, a quick 1.7 today because 1.7 is comprised of just a lot of terms and definitions. And you've made it to ninth grade, so I have to believe you can read. So I will read through them quickly, just kind of stressing some importance of the definitions today, and then working through the one or two examples within this section. So we're looking at identifying terms related to three-dimensional figures. Solid geometry is the geometry of which the world we live in. Okay, that's why I like geometry so much. It's the thing we can feel, we can touch, we can build, we can measure it. A lot of times in algebra, it's really hard to understand parabolic functions because we can't build them. We can't hold them in our hands. We can't stretch them out and look at how it changes. So that's the one nice thing about geometry. So let's go through some definitions. Okay, a surface is a connected set of points in space. It has the thickness of a point. Does a point have thickness? No. So a surface is really just a connected set of points. Okay. A sphere. A sphere is a set of all points in space that are a given distance, north, south, east, and west from the center. Okay. It has a radius. Spheres are your basketballs, your volleyballs. We all know what a sphere is. The next one is a cone. Okay, I want us, when we think of cones, to just automatically think of ice cream cones. A cone is the union of a region, which is the base, that connects the boundary of the region with a specific non-coplanar, a point that is not on the plane of the base, which we call the vertex. Okay, so think of your ice cream cones. All right, the base is the region in the plane bounded by the simple closed curve. Most of the time when we think of an ice cream cone, that's the circular base, right? And then the lateral face is the surface that is formed by line segments connecting points on the base to the vertex. Now the vertex is non-coplanar. It's not on the same plane as the base. It's really hard to draw with this pen because I've tried to draw dotted lines for the back, but that's what it is. Okay, so the vertex is up on another plane. It is not on the same surface as the base, thus making it three-dimensional. A cylinder is the union of two exactly the same size and shape regions, but they're in different parallel planes. So in our example here, we have two parallel ovals, which creates the top and the bottom bases, and then they're connected, so that makes it a cylinder. Anything that is circular has a circular base. That's kind of one of our definitions. A pyramid is a cone, but the base of that is a polygon. Okay, so instead of it being a circular, it will be a polygon with segments creating the base. Like this example right here, this is a square pyramid. I could argue that that might be rectangular. Now you notice this little word out front, right. What that means is if you dropped a plumb line, if you dropped a line from that vertex, point D, if you dropped a line straight down, it would make a right angle with the base. That's what a right square pyramid means. Okay? Sometimes we can have them to where they are, this is going to be a horrible drawing, slanted, like that, to where if we dropped a plumb line straight down, it would hit either on the outside or not in the middle. Okay, so that right pyramid means if we dropped it straight from the top of that vertex point at the top, it would go straight to the center of the figure below. forming a right angle. So this one still would form a right angle, but it's not inside that polygon base. Okay, it's not within that polygonal base. We'll talk about that more in class, just so you know. So right means it's straight up and down. If it's not right, it's kind of slanted looking. A prism is any cylinder. So a prism is a cylinder, but prisms have polygonal regions as bases. Okay, so like over here, this one right here, that looks like a pentagon. That would be a pentagonal prism. There's a pentagon on plane 1, there's a pentagon on plane 2, and we are connecting the vertices of those two to make it a prism. You can have a right, which is what we talked about earlier, oblique, okay, means it's slanted, or regular, regular meaning all the same size and shape, pyramids and prisms. A polyhedron is a closed surface made of polygonal regions. Each polygonal region formed by the surface is a face. So looking at this soccer ball right here, all of these pentagons in here are the exact same size and shape. And this soccer ball is made up of all of these different pentagons, okay? Or hexagons, because the white ones are hexagons, the black ones are pentagons, right? Yeah. All right, makes sense? Easy enough? Okay. So let's look at this next slide real quick. Let's look at example number 1. Use the right square pyramid illustrated to the side to name the following. Its vertex. Its vertex would be point D. That point up at the top that's not on the same plane. All right, so D. Oh, I can write it. Its base. First of all, it's telling us it's a right square pyramid. So its base would be square LMNO. So square LMNO. Square LMNO. C, name a lateral face. So these are the sides that go from the base up to the vertex. Well, all of these are triangular shape, so I'm just going to pick triangle ODN. There's a bunch of others. There's MDN, there's MDL, and there's ODL. Those are all lateral faces, so there's 4 lateral faces here. And last but not least, it says name a lateral edge. Now, a lateral edge is the line segment. So for example, right here, the lateral edge is segment DN. Okay. All right, so let's look at example 2. Example 2 says classify each figure as a polyhedron. Then classify any cones or cylinders as specifically as possible. All right, so when we're looking at these, we need to check the sides. If we look over here, I've kind of given you a cheat sheet, right? So the thing we need to think of is how many faces does this have? Okay, and what I mean by a face is a flat surface. So look at this guy. I've got 1 right there. I've got 2, this is going to become a hot mess, on the bottom. I've got 3 over here. And then hopefully your mind's eye sees the one in the back, which looks like this. That's 4. If we have 4 sides, it is a, right there, tetrahedron. Oops. I'm just going to write tetra. Okay, so that's a tetrahedron. You could also say it's a triangular pyramid because there's a triangular base on one plane, a vertex up at the top. So you could also call it a triangular pyramid. B looks like 2 triangular pyramids stuck together. So once again, if we look at the different number of sides, we've got 1, 2, 3, 4, 5, 6, 7, 8. So we have 8 faces. If we have 8 faces, It's an octahedron. I'm just going to write octa. C. C, you could probably call this a quadrilateral prism or rectangular prism, but if we wanted to name it as a polyhedron, we have to look at the number of faces. So we've got 1, 2, 3, 4 side faces, then 5 and 6 faces on the top and the bottom. So 6 faces, again, if we look over here, is a hexahedron. Hexahedron. D, we know this is some type of pyramid. And once we look at the base, that is a pentagonal pyramid. And we know if it's a pentagonal pyramid, it's got 5 sides of the base. So that means there's 5 lateral surfaces going up, plus the one on the bottom, which makes us 6 lateral faces, or 6 faces. So it, again, is a hexahedron. So these two are both hexahedrons, but one is a pentagonal pyramid and one is a quadrilateral prism. Okay, so you kind of have to specify. You can't just say hexahedron. You need to specify hexahedron quadrilateral prism or hexahedron pentagonal pyramid. Okay, last but not least, this one, well, I don't know. There's a whole bunch here, right? There's a whole bunch here. Maybe your eyes are better than mine. But at this point, you know, if I'm looking at my surfaces that I'm seeing 1, 2, 3, 4. I'm seeing 4 right here, and I know it's going to go around at 4 more times. So that's 16. Then I know there's going to be 1 more at the bottom. 16 plus 4 is 20. So that's an iso... Oh, I spelled it wrong. Isohedron. Yeah, hard to erase. Okay. All right, moving to the last little bit. Like I said, there's not a lot today at all. It's mostly definitions. Your last definitions is what we've kind of already talked about, regular polyhedrons. It means every face is the exact same size and shape. Okay, they have the same number of edges, meeting at a vertex. They're all identical. All right, complete that TRF, and we'll work through some of these tomorrow.